Alrighty, so in this video we're going to be going over a summary of transformations. And again, it's an excellent opportunity to use Desmos here to see the transformations happening as we're changing the function. Alright, so let's get to it. So given real numbers a, b, c, and d, and a function f, the graph of y equals to c times f of a times x minus b plus d can be obtained by the graph of y equals to f of x in the following steps. And this is the order that I would like to follow, and I would like you guys to follow in case you encounter transformations. So let's take a look. The very first thing that I want you guys to do is focus on the function if you have f of a times x. Now notice that the transformation that is occurring right now, it is inside the function. So whenever you see a multiplication and let's say inside a parenthesis for a function, as we'll see in the case for the x squared, then that means that the transformation that is happening is going to be a horizontal scaling by a factor of 1 over the absolute value of a. And in the case of a being negative, then it's going to be a reflection across the y-axis. So let's take a look at the quadratic function. Again, it's a normal parabola. We're familiar with it. So now let's see. Let's say that I try the function f of 2x, for example. Okay, so we see the graph here being represented by blue. Now it seems like the parabola itself, it's a little bit steeper, right? Now what do we mean by the horizontal scaling here? Well, right now I am using function notation where the input is 2x, but if it makes it any better, I can also rewrite some other function, let's say g, and I'll do it here. Let's say g of x, and if g of x is the same thing as, let's say, as f of 2x, or let's take the input being 2x, remember the function f was x squared, and if the input is 2x, then it's going to be 2x, the input, squared. So you see, it's the exact same graph, however you guys want to interpret it. Now let's take a look at what do we mean with the horizontal scaling. Well, I want you guys to pay attention to, let's say, when x was 2 on the original function, the black one, then we got the y value of 4, right? And that makes sense because if I put in here 2 squared, I get a 4. It's not sticking there. Yeah, no, I can't get it to the point to stick. It's okay, it's fine. Well, let me put the point here, the coordinate. On the original graph of f, we had 2, comma, I'll just put here f of 2, that's the y value, which we know it's 4. And there we go. And let's put a label there. There we go. So there we go. That's our point 2, comma 4, and that is on the original graph. Now on the transformation where we had f of 2x, or alternatively 2x squared, notice that on the new function, the y value stays the same. It's still at a 4, but now it is the x value that was changed, hence the horizontal scaling. Now how was it changed? Well, it was divided by 1 over the a. And what was the a? Well, the a was 2 here. So we see the 2 divided by 2 is equals to 1. And I'll put it here on the new graph. Let's see. Now remember, it is the x that's being divided by the a, and the x was 2 divided by the a, which was also 2, comma, and then let's go for our f of 2. And there we go. Let me put this in green. There we go. So yeah, remember guys, the whole key here is whenever you see a multiplication that seems to be inside the parentheses, you don't change the y value, but instead you divide the x by whatever the a is. Okay. Alright, so now let's take a look at another transformation. Now what happens if after multiplying by some a, you also have some x minus another number? Well, this one here is going to be a horizontal shift. So again, horizontal means changing the x of b units. But we got to be careful here because whatever we're subtracting inside the parentheses here, we're going to be doing the opposite in the graph. Now, what do I mean by the opposite? Well, let's say that I have, and again, focusing on the quadratic, let's do a shift by 2 again. There we go. Now we have a new graph, but this one seems to be shifted. Now notice that we're subtracting by 2, but rather than shifting to the left, you actually did the opposite and ended up shifting to the right. And that's what happens whenever there's horizontal changes. We just saw it with the with the horizontal scaling, where we were multiplying by an a, but what we actually ended up doing was dividing by an a. And it's the same thing here. If we're subtracting by a number, what we end up doing is actually shifting to the other side. I'll use the g notation again rather than the f of x minus 2. I'll just say that, okay, well, if we have g, and that's an x minus 2, that was the inside, and the function was telling us to square it. There we go. Both interpretations are the exact same thing, and we get to see it here that, hey, what we ended up moving was by 2 units to the right. Every single point got shifted. Okay, now it's highlighting it. I don't know why it didn't on the other one. Let's say the case when x was 2 on the original graph, then it ended up shifting by 2 units to the right. So the y value again remained the same. The one that is changing is the x. So takeaway here is whenever there's changes inside a parentheses, we do the opposite. If it's a multiplication, we actually divide. If it's subtraction, we actually end up adding. Or if it was an addition, we actually end up subtracting. So let's change that here to a plus 2. There we go. So you see, rather than moving to the right, we had that I'm moving to the left. Okay. All right. So now let's take a look at another transformation. And that is the transformations that are occurring outside the parentheses. And those ones are a little bit more straightforward because there's no doing the opposite. We're doing exactly what the numbers tell us to do. So let's take a look at the example here where we have y equals 2. Now we're multiplying c times all the previous changes, f of a times x minus b. Now this is going to be a vertical scaling, meaning that we affect the y values by a factor of c. Now in the case where the c is negative, then that's going to be a reflection across the x-axis. And let's keep on using our example for the parabola here. Now let's say that we do f of, I'll just put here 2, let's go with 3 times f of x. Okay, so now what's the change that happened? Well, let's take a look at one point, and let's say I focus on the point, let's go with 2. So when on the original graph, we had 2 comma f of 2, which was 4. There we go. Now the new change is affecting the y value. It's not affecting the x's. Whenever it's outside the parentheses, then it is a change on the y values. So the new point is going to be with the same x coordinate 2, but now the y value is the one that was multiplied by 3. So we'll put here 3 times f of 2. And see, that is the new point on the graph, which is basically, hey, you take the y value, 4, you multiply by 3, and you get 12. The x did not change. It remained at 2. And that's what I was saying, that these changes are a little bit easier. We don't do any opposite. We just say, okay, well, if there's a number c multiplying the function, then we multiply the y value. The x's don't change. Now, the last and final change here, it's probably the easiest one. It's whenever we are adding or subtracting another number d. Well, that is going to be a vertical shift by d units. So again, we're moving in this case up or down depending on the number that we're adding or subtracting. So let's say that we try it here with let's just say f of x minus 3. Actually, let's go plus 3. There we go. So now it seems like all that we ended up doing was taking the y values and then shifting them up by 3. So you see here the x's remain the same, 0, 0, but the y values we were adding 3. And it's the same for all of them. Again, taking a look at the 2 here. Yeah, I don't know why it never does it, but so we have 2, 4. The new point on the graph is going to be 2, then we take the 4 and we add 3. And there we go. That is the new point right here. So that is the idea with the transformations. If there's changes inside the parentheses, those are changes in the x's. So it's going to be in either a horizontal scaling or a horizontal shift while doing the opposite of what's inside the parentheses. If it's a multiplication, we divide. If it's an addition, we subtract. And then there's the vertical changes, either scaling by a multiplication, if it's a number multiplying the function, or by adding or subtracting whatever d is. Okay, so with that said, let's take a look at one example and see those changes happening in a new graph. This time around, we're going to be focusing on an absolute value graph. So we want to use the graph of f of x equals to the absolute value of x to obtain the graph of g of x, which is equals to -2 times x plus 1, or the absolute value of x plus 1 minus 3. Okay? And again, we'll be using Desmos, but for now, let's just do it without Desmos, and then we'll verify our work here. Alright, so the first thing that I want you guys to do is graph the original function. So what was the original function? In this case is the absolute value of x. So the absolute value of x is a V shape right here at 0, 0. Then if x is 1, the absolute value of 1 is 1. The absolute value of 2 is 2. And I'm going to do it here in a dashed line. Okay? And now let's go for negative values of x. If x is -1, the absolute value of -1 is 1. The absolute value of -2 is 2. So there we go. We are getting the nice V shape. Alright, so here's the original graph. Now let's take a look at the transformations. Alright, now remember, I want you guys to start off by identifying a multiplication or division inside the parentheses or inside the function, or in this case, multiplication or division inside the absolute value. And I don't see a multiplication or division inside the absolute value, but we do have an addition of 1. Okay, so there does seem to be a horizontal shift in this example. Now remember, the horizontal shifts, we're doing the opposite. So if it's a plus 1, what we're actually doing is taking the x values and subtracting 1. So I'm going to begin here with the first point at 0, 0, and I'm going to take away 1 from the x's. So now I'm at the -1, but the y stays the same. Now the other point, let's say right here, which is at 1, 1, I'll take away 1 from the x's, so now I'm at 0. This one here was at -1, take away 1, so now I'm at the -2. So there we go. We shifted everything to the left by 1 unit. And I'll write it here, first change. And let me write down transformations here. There we go. And the first one here was a horizontal shift by -1 units, or 1 unit to the left. There we go. Okay, so what's the next one? Alright, so we take a look at any multiplications outside the function, or in this case, any multiplication outside the absolute value, because again, our function was the absolute value. So it does seem like we have a multiplication here by -2. And remember, those type of changes, since they're outside the function, though they are applying to the y values. So let's see, let's write that second transformation. It is going to be a vertical scaling by a factor of 2. In this case, -2. Might as well incorporate it. So let's multiply everything by a -2. Well, when I say everything, I mean every y value. Okay, so there we go. Now let's see. I'll label the points right now. This point was at -1, 0. This one here was at 0, 1. And our point right here is at -1, 1. Okay, so now we're going to be applying the vertical scaling to the y values by a factor of -2. So taking the positive 1, multiplying it by negative 2 is going to take us at 0, negative 2. Again, the x did not change, it was only the y. Now this point here at negative 1 comma 0, if I multiply 0 by negative 2, I'm still at 0. Then our point right here at the negative 1 comma 1, multiplying the y value by negative 2, it's going to take us here to a negative 2. There we go. So we see that change is coming together. Now let's see, last but not least, we do have a subtraction of negative 3. Alright, so it's outside the absolute value, it's outside the function, so it means that we're affecting the y value again, and this time around we are shifting it by 3 units down. So another vertical shift. Okay, so now let's apply the change. If this point right here was at 0 comma negative 2, this one here was at negative 1 comma 0, and this one right here was at negative 1 comma negative 2. Then shifting the y values by 3 units, 1, 2, 3, there we go. We're going to be at 0 comma negative 5. This point here is going to come down 3 units, there we go, at negative 1 comma, I'll put it here, negative 1 comma negative 3. And last but not least, we're going to have our point right here at negative 1 comma negative 5. And this should be the resulting graph. And this is the g of x. So remember, first thing to note was there was no multiplication to the x inside the absolute value. There was only an addition of 1. So that's why we did a horizontal shift of 1 unit to the left, the opposite direction. Then there was a multiplication by negative 2 to the y values, so it was a vertical scaling by a factor of negative 2, or alternatively could have said a vertical scaling of 2 with a reflection across the x-axis. And last but not least, the minus 3, which was the vertical shift by 3 units down. So now let's see how this one compares in Desmos. So let's see here. Okay, now let's write down the new function. Okay, there we go. I set it up here in Desmos. We have the original function, f of x is equals to the absolute value of x. Okay, then the first change that we did was the horizontal scaling. We see it here, the x plus 1, ended up shifting everything to the left. Then the next change was the vertical scaling by a factor of negative 2. So we multiplied let's put every point here. Oh, whoops, I just realized that I labeled this point incorrectly. This was at negative 2. Because it was originally at the negative 1 comma 1, so this one is now at the negative 2 comma 1. There we go. So this one should have also been changed. It was the wrong label, but it's at the right point. And last but not least, yeah, this one also changed, because it was at the negative 2 comma negative 5. There we go. There we go. Now it is matching here at the negative 2 comma 1, and then at the negative 2 comma negative 2, just like we have here. And now the last step on the final change was the shift by 3 units down, and there we go. I'll get rid of the other ones and put back the original. So this is what we ended up seeing here. We got our point right here at negative 1 comma 3, at 0 comma negative 5, and at negative 2 comma negative 5. There we go. So yeah, guys, so this is it for transformations. Overall, it's not too bad, but it's a very powerful technique that allows us to avoid point plotting every single change in a graph. We just need to know how the numbers are affecting the graph, because it's going to be the same for all functions. And that's why I kept things here general with the A, the B, the C, and the D, and just keeping the function notation, because again, the f could be any function, and it's always going to be the same type of changes. Okay? Alrighty, guys. So if there's any questions for this, again, please let me know when we meet on campus. Alright? See you in the next video.